Anjul. Good morning. It's a great pleasure to be here and be amongst the community to celebrate Apache Spark. So, what started, I believe, 6 years ago, which was a kernel at the time, Matej Zaharia's PhD thesis at UC Berkeley. We are all excited that now it is the most active top-level Apache project. And IBM has a storied history of betting on technology that is game-changing and has stood the test of time. And we believe Spark to be that technology. Really never before have such a rich set of capabilities all come together in one platform. Spark is really the single toolbox for analytics. So we at IBM believe that Spark is the analytics operating system. Now, why do we think that? So, if you have structured data, you can use Spark SQL. If you have unstructured data, you can drop to Spark Core. If you're getting data from one of those fire hoses, you can use Spark Streaming. You want to build models. You want to learn from networks of data, use MLlib, use GraphX. And what is really magical is that all of these components interoperate seamlessly. Like in the past, to leverage these kinds of capabilities, enterprises would have needed maybe half a dozen products, each with its own nuances. And now you can accomplish all of this in just one single platform. And what we think are the key capabilities of Spark that make this possible? One is the expressiveness, and second is the speed. Spark has really expanded the range of big data problems that can now be addressed. And it has given us a very enhanced solution vocabulary. It has really taken distributed computing to a whole new different level. If you can visualize the value locked in your data, Spark can help you find it. And it does that with speed. So through smart use of compute, disk, and memory, it has handily sped up even the traditional big data technologies or capabilities like MapReduce by 2 to 3 times. And it doesn't stop there. It has made the developers much more productive, that they can now develop applications in a fraction of time and with less lines of code. So this is, truly phenomenal. And at IBM, we are enhancing Spark, so we are part of the community. We are doing work all the way from hardening the documentation, to fixing bugs, to contributing features in Spark SQL, in Spark R, and as well as contributing significant IP like SystemML, which is a machine learning algorithm optimizer to the machine learning community, and integrating it with MLlib. We are also offering Spark as a part of our product, like Big Insights, so as to make the transition from Hadoop workloads to Spark seamless. We also offer it. We just announced a service, Spark as a service on the cloud that was just made generally available yesterday on the IBM Bluemix cloud. And we are leveraging this inside our products. And I'll give you a quick glimpse of how we are leveraging Spark inside our product portfolio. So we already, in a very short amount of time, have about 15 products in the market that are using Spark. And we are working on at least a dozen more. And those will be soon coming out over the next 6 to 8 months. So we have leveraged Spark all the way from our infrastructure, traditional products, to new offerings. So in the case of ETL and data shaping, for example, we were able to re-platform our ETL product to use Spark in about 1 year. And the product that used to have 40 million lines of code has now been re-implemented, and by leveraging Spark, it is down to 4 million lines of code, which is why I was making the point around developer productivity in terms of how we were able to develop a product with such rich capabilities in about 1 year, and from 40 million to 4 million lines of code is something extremely substantial. Similarly, in the case of SPSS, which has our predictive analytics capabilities, by using the push down to Spark and by leveraging MLlib and system ML, we are able to speed up. We have seen this, that the predictive model building and scoring, so the execution, has sped up from 3 to 6 times over hundreds of terabytes of data, which is, again, very, very, we are very excited about that. Now, our Watson Analytics platform leverages these new ETL capabilities, as well as the large-scale predictive analytics capabilities, and is now able to leapfrog to interactive and guided visual analytics. We are also building new analytics-infused applications like price optimization, like predictive customer intelligence. So this is just a small glimpse of what's happening in our portfolio. And I'll share a couple of examples as to how IBM customers are using Spark. So like Matej had pointed out, that banking and finance industry is where we are seeing a lot of uptake. So one of the examples that I was going to share here is from the finance industry, and it is one of our banking customers. So, and this doesn't apply to just this bank, but that's the use case that I'll share. So they have dozens of systems that are producing millions of transactions every day. And these transactions, they flow into a data lake, which is also reaching the size of about petabytes of data. And they have thousands of analysts that want to run reports, and they are all seeking what is called as the single version of the financial truth. But the problem is that each of these reports touches almost the same amount of data, which is petabytes of data. And if these reports were to be run individually, they will never get completed till the bank opens the next day. So to solve this, what we've done is we have created what we call as the scan sharing engine, and we consolidate all the reports and run them together. The data is touched only once, but we can produce hundreds of different outputs. And Spark is helping in many ways. I'll call out the two really important ones. One is obviously the obvious one, which is the horizontal scale-out that Spark provides. And second, once we have processed each of these reports through the scan sharing engine, then we rely on Spark SQL and data frames for things like groupings and aggregation. And this is something that we cannot think of any other technology that would have helped us to touch this petabyte of data only once and produce these hundreds of outputs and be able to do this before the bank opens the next day. Another example that I have is from one of our ISVs in the telecommunications space. Their customers are now interacting with them through multiple channels, right? First, it used to be that they had information about their customers in the systems of record or in their warehouses. But now, these customers interact with them using making calls, voicemails, emails, text, social media. So the number of channels and the number of interactions with the customers are increasing. But they have two problems. One is that they do not have an easy way to get a complete, or what we call as the 360-degree view of the customer quickly. The other issue that sometimes the customers face is that even though they have provided the information, as the channel of interaction changes, they have to provide that same information multiple times in what the customer considers as a single interaction. And that is dissatisfying for the customer. So the solution that we built with them, it integrates all of these touches that the customer has with the business to create a trail, and which the ISV refers to as the customer experience journey. And then they run models on this journey to score the customer satisfaction index per agent and per channel of interaction. And how is Spark helping here? Spark's connector API and Spark streaming is used to help bring all the data together into a single data lake. And Spark SQL and some custom transformers are run over this data to extract some of the text and do the voice processing. And these used to be ETL jobs that used to take about 8 hours per batch. And now they have seen a reduction in this to about anywhere between 2 hours to minutes, depending on, obviously, the complexity of the transformations and the jobs that are running. Now, a sequence algorithm written in MLlib stitches all these interactions together to create what is called as the journey data. And a set of models are run on this journey data to score the customer satisfaction index per agent and per channel. And Spark SQL is used to build visual dashboards where the agents can get a complete view of the customer as they are dealing with the customer. They can see what the customer satisfaction index looks like so that they can get a feel for how to deal with the customer, if it's a really unhappy customer that is coming, or it's a moderately satisfied customer that is coming, so that they can give them the right attention that is needed, and also figure out why they're dissatisfied, what was the reason for that, which was very difficult for them to figure out before. So now you see that this is all these different capabilities that have been leveraged to build the solution, and the ISV never had to move out of the Spark stack. And this is the power of the expressiveness and the rich set of capabilities that are coming together. Now, in addition, the benefit that the ISV has seen is that the cost of the infrastructure and data processing has gone down by about 70%. And the number of lines of code that were needed to build this solution were, again, much smaller than their earlier solution. So this is why we consider Spark to be the analytics operating system. And we have our Spark Technology Center in San Francisco. It's in shouting distance of our open source partners, Databricks and TypeSafe. So if you find yourself in the beautiful city of San Francisco, please do stop by. For those of you who are already on Spark, welcome to the revolution. For those of you who have big data projects or problems and you're still trying to decide what to use, I would say come on board. And as for our own Spark journey at IBM, I invite you to track us at this website. Thank you.